Hi everyone, this is Ed, the Audio Nut, and Radio Amateur W8EDW. This is my amateur radio station that you're looking at, and it truly is a radio station. It broadcasts to the air, just like the commercial stations do. And I thought it would be kind of a fun project to make an on-air sign like they use in the commercial studios to let people know when the studio is in use and when you have an open mic. So that sort of prompted this project, and I think it's going to be lots of fun. So we're going to get started right now. So building this project, one of the first things that we needed was a box. I found this cool box. It's just an electrical box on Amazon. The cool thing about it, it has these little tabs here that allows you to open it up. It's waterproof and all that. Of course, that isn't that important here, but anyway, very inexpensive. I think this thing was like $7 or something like that on Amazon. That's the number on it, and it's going to be a good, easy-to-use project box. It has lots of room, and so that'll be the first item. So we're going to need a relay to switch the light on and off, and this will be triggered from our transceiver or transmitter send, which we'll get into that a little bit later. But I found these relays on Amazon. You get 2 of these things for like $8, and unbelievable. The neat thing about these is that they isolate the coil from the switch, so that way you've got a buffer and it doesn't give you that back EMF that you might get from the coil itself if you were just going to strictly use a coil relay. So I thought that would be kind of a cool thing to incorporate this into our design. And here is the item number. It's called Hilt2Go, H-I-L-L-E-G-L-E-T rather, G-O. And that's the item number on it. So very cool. We'll get into hooking that up in just a bit. We're going to need an electrical outlet. This is going to be actually a 110 outlet that the relay is going to switch. We're going to have a USB power supply plugged into this because the sign uses a USB cord and actually uses a 5-volt USB to light it up, and works pretty good. I'll show you guys what it looks like here in a minute. But anyway, that's the outlet that I'm going to use. And then the number is right here. See if that thing's going to focus. That's the number, and I got that on Amazon. You get like 3 of these in a package. And then again, very cheap. I think it was like $6, and you got 3 outlets in one bag. Pretty cool. So here's the actual on-air sign, which I got on Amazon, of course. It's a really nice, nicely made. It's plasticky, but let's face it, what isn't these days? But anyway, it comes with the cord, and it's a USB style cord that you get power from, and then it just on the other end has the standard, USB plug on it. And that's the only thing it didn't come with. It didn't come with the power supply to actually power up the USB, but those things are so common. I've got some of those laying around in here, but this is the number and so forth of the sign itself. But pretty cool. I've lit it up, and it really is pretty darn bright. So anyway, let's see, what else do we need? So we're going to need a DC socket, and then again, you can find these on Amazon, and a plug to fit it, which this plug also you can find on Amazon that mates to that. That's going to be the DC switching voltage that's going to be coming out of our radio. So that those two components you definitely need. So the next thing you need is an accessory plug, which my ICOM 7300 actually came with this. It allows you to plug in the accessory socket in the back of the radio, and then there are different things that you can do through that socket. One of them is it actually has the send available, which is what we're going to use to key the light relay, and then it also has 13.8 volts available on one of these pins, and we're going to use that as well to key the relay. So hopefully your radio has an accessory plug of some kind and a send output on the radio. That's all we need to make this work. So let's take a look at the accessory plug and socket on the ICOM 7300. The two pins that we're interested in is number 3, which is the send. So that would be over here, pin number 3. And then the other pin that we need is number 8, which is the, let's see, what is that? 13.8 volts. So we're going to need number 3 and number 8. Now we need to know what colors those are. So we'll take a look at that. Number 3 being the orange over here, and then number 8 being the gray wire at the top. So that way we'll know those two wires are the ones we're going to need to hook up to our relay to make it work. 13.8 volts is going to be the positive coming out, positive voltage, and the number 3, the orange wire, is going to be what triggers the relay. So this is the way I hooked up the accessory plug. I soldered the orange wire, which is number 3, and also the number 8, which is the gray wire, to just a standard pair of wires here. And what I did is I soldered them, and then I put some heat shrink over it to kind of protect it. And I just zip tied the rest of the wires together. I've got a piece of heat shrink I'm going to slip over the whole thing to kind of protect it. And then, of course, on the other end is just the DC plug that's going to go in to trigger the relay box. So that's the setup on that. So here's the relay. Because the connections are so small, I'm going to show you on this block diagram that I drew up how the connections go on it. But basically, you just have a positive voltage coming in, the ground side over here, and then we have a jumper to tell it which relay we want to trigger. So if you look over here, I just kind of blew everything up so it's a lot easier to read. 13.8 volts is coming in over here. That's the first terminal. The second one is going to be our number 3, which is going to end up being a ground, the DC negative. And then we've got a jumper wire that's going to go from the positive voltage over to whichever relay we want to trigger. In this case, I'm going to use relay number 2. So we just put the jumper wire over to 2. Now every time this voltage comes in and engages this PC board, that will automatically also trigger number 2 relay. Over on this side are the outputs for the relay, and this is normally open circuit here, that when it's triggered, of course, that will close. And then here's our common. So you'll notice that the plug that plugs in the wall, the AC plug, comes in and it goes into the number 2, normally open. Then it goes through to the common. The common is hooked up to our outlet that we're going to put in, and then that comes back and completes the circuit. When the relay is thrown, that'll connect these two together. So that's how it works. It's pretty simple, really. And this relay does a really nice job for an inexpensive price. So I wanted to hook it up to the 12 volts just to see it work, the mechanical part. So I'm going to plug it in to the power supply right now. You can see that the green light came on right over here. That lets me know that there's power going into the PC board. And then I've got this red jumper right here, and going to connect that to the relay. And right there, the red light came on over there next to that relay. That's relay number 1. And then right next to that is relay number 2. So just by moving this jumper wire, I can tell it which relay I want to kick in, and then also if I want them both to come on, I just daisy chain them, and they'll both come on the minute that it sees the 12 volts coming in. Actually 13.8 from the ICOM will be coming in. But anyway, I just want to check it out electrically, make sure it was cooking, it looks good, and the relays sound like they're snapping as I touch the wires to them, and I think we're good. Can you hear that? So those are the 2 different relays clicking. So anyway, now it's going to be a matter of mounting everything. That's going to be the next step here. So I'm going to start working on that right now. I've got the box mounted in a vise, and this is the first item we're going to mount. This is the electrical outlet. It looks like it's designed so that you push it through a hole and then it sort of snaps into place. So what I'll do is use a hole saw to cut the hole fairly large, and then what I'm going to do is use this thing called a nibbling tool. I bought this just for this project, and I needed one anyway. And what it does is just nibbles away at the edge of your hole. You just squeeze it like this. The top comes down and it kind of nibbles away at the edge. So it'll be interesting to see if this works. So I'm going to get going on drilling the hole, and we'll see what happens next. Well, there's the hole completed, and I used this, it's a 3/4 inch hole saw, and just a standard one, you know, to go in your drill. Not a big deal. And we'll see if this fit in it. Put the wires down in there. But see how close we are and how much nibbling we need to do to make it fit. Seems like it fits almost perfect in the hole. I'll have to nibble away a little bit on it to make it snap in. But I'm going to work on that, and we'll see if I can get it in place. That'll be the first major hole and major piece that we have to put on this thing. Oh, there it is in place, and believe it or not, I didn't have to do any nibbling hardly at all on the hole. I just shoved it in and it snapped into place, and that was that. So pretty happy about that. So the next hole was for the electrical cord and the grommet. And basically that's just going to go in there like that, and the grommet will push into the hole, hopefully. There we go. And the other end of the cord, of course, is just, you know, standard AC plug. That's going to actually power up the AC outlet here when the relay is engaged. And then of course our USB power supply will be plugged into that, and that power supply will feed the sign then. So there we go. That fit pretty good. The grommet fits in there good. So we've got the AC side at least mounted pretty good now. And so now I'm going to flip the box over and we're going to put the DC side on the other end. So on the other end of the box, I drilled a hole for the DC socket. I kind of wanted to keep the DC away from the AC, so that's why I put the AC on one end and the DC on the other. But here's the socket that goes in there, the DC socket that we've got. See how it fits. All right, goes down in there pretty good. Yeah, that's going to fit nice and clean. So pretty much the drilling for the bigger stuff is done. I've got to mount some holes now for the PC board to mount it down in there. And we'll be on our way to being done. The next step, and hopefully the final drilling, is going to be to mount the PC board. So we're going to make sure this is lined up. We'll mark the holes, get that drilled, and then we can mount it. And we'll be darn close to getting everything done except for wiring it up, which shouldn't take long at all. I got the holes drilled, lined it up, pushed the screws down through the holes to make sure everything lines up, and it's going to work fine. So the next step now is going to be, we're going to open the box. We're going to wire the wires to the PC board, and then we're going to mount the PC board into the box. So we're almost there. Let's take a look at the AC side of the box. This black wire here, the one that plugs in the wall. The color coding on it is pretty standard for house wiring. The green wire is your earth ground. The white wire is the return ground from the outlet, and then the black is the hot side of the outlet, or the actual cord coming in. The outlet that we installed in the box uses the more traditional electronic color coding, where the red is the hot, the yellow is earth ground, and then the black is the return ground from the outlet. So those are the color codes. We're going to get this together and start wiring some of the things up that I'm going to wire nut together. I'll show you what that is in just a second. I got the PC board mounted in the box, and wanted to show you some connections here on the AC side that get wired nutted together. The yellow wire coming out of the outlet here is the earth ground, and that's going to get tied to earth ground to the cord coming in, the AC cord, which is green. So those two are getting tied together. And then the other two return grounds on the outlet, it's black wire, and then on the cord coming in, it's a white wire. So we tie those two together. And then what we want to do is switch the hot side through our relay. And what I did was I brought the number 2 relay connections in right here. And there was a normally open contact that I put the hot wire from the cord, which was the black wire, and then the red wire from the outlet is going to the common on that. So when the relay kicks, what it's doing, it's bringing the AC power in, it's going through the switch, and then out to the outlet to make sure the outlet side is hot. And then, of course, we're going to have our power supply for the sign plugged in to that outlet there. So that's pretty much the AC side. And then over on the DC side, you can see where I got the connector put into the box. The red wire goes to the positive, and the black wire goes to the negative. And then we've got a red jumper wire that we're jumping over, and it's going to go into relay number 2 input. So that way, when this kicks on, relay number 2 kicks on, and it energizes the outlet. So that's the basic setup on that, and now it's just a matter of doing some testing on it. We'll try that now. So I want to do a bench test on this first before I hook it up to the radio. And so what I did is I went ahead and hooked up the power supply right here for the sign. And then I have the AC cord going out to the outlet in the wall to bring in the power. And then now it's a matter of just plugging in our DC. I've got a 12-volt supply here I'm going to use. I'm going to plug that in, and hopefully the light will light up, and it does. Isn't that awesome? I used a clear box for a reason. I wanted to be able to see the LEDs in the relay working. I thought it was pretty cool. So anyway, we know it works, and now the next step is to hook it up to the radio. We're going to be doing that next. This is amateur radio W8EDW calling CQ, Whiskey 8, Echo Delta Whiskey, amateur radio station W8EDW in Columbus, Ohio. So what'd you guys think? Kind of a fun project, and I think it turned out pretty cool. Just something fun to add to the ham shack. Impress your friends, and so forth. But anyway, if you enjoyed the video, please give me a thumbs up. And subscribing to the channel just helps me make more of them. So thanks so much for watching. I appreciate it a lot. And we'll catch you on the next video.